Hey guys, okay, so there's a couple of things that I want to talk about that we've kind of been mentioning in class, but I want to go into a little bit further here. First thing is the Bronsted-Lowry conjugate acid-base pairs, okay? So if we look here, my groups have defined that if you have a conjugate acid, it's the particle formed when a base gains an H+, or the conjugate base is a particle that remains with an acid when it's donated by an H+. Okay, so a conjugate acid-base pair is going to be on either sides of a chemical reaction. Okay, and we have to remember that acids will donate the H+, and bases accept the H+. And then whatever on the other side of the chemical reaction it links up to is going to be its conjugate. So if we look at this example, NH3 and NH4 are going to be partners, where H2O and OH are going to be partners. Now I have to look to see what's happening on either side of the chemical reaction. So NH3 is going from NH3 to NH4, which means it's gaining a proton. So that makes this the base, okay? Where H2O is going from H2O to OH, which means it's losing a proton, which makes it the acid, okay? So now on the other side of the chemical reaction, that means that they're going to be the opposite of what they were on the reactant side. So for example, if I have a base here, that means that the NH4 is going to be the conjugate acid, where the OH is going to be the conjugate base. Okay, so let me look at one more example, and then I'll let you guys do a couple of these, and then we'll do some in class as well. So HCl plus H2O makes H3O plus Cl. So HCl matches up with Cl, and H2O matches up with this H3O plus. So HCl goes from, and this should be a one-way arrow, I'm sorry. HCl goes from HCl to Cl, which means it's losing a proton, which makes it the acid, or in this case, water is acting like the base, okay? So on the other side is going to be its conjugate. So since this matches up with the Cl, that means that this is the conjugate base, where the H3O plus is going to be the conjugate acid, okay? Go ahead and try these two examples, and then we'll look at them in, after class. You'll notice from those examples that water can act like an acid or a base. And this is very important when we start talking about how do we calculate pH. Okay? So water can do this thing called self-ionize. And since we know what ionization means now, what that basically is saying is that water will split up into these two ions. H3O plus, which sometimes we write as H plus OH minus, okay? In a neutral solution, so you guys know neutral means a pH of 7. In a neutral solution, the H plus concentration, or like we have written up here, the H3O plus concentration, is equal to the OH concentration, which means nobody wins, okay? And that's why we get a pH of 7, okay? And that is 0.000001 molar, which is equal to 1 times 10 to the negative 7th, okay? So let's think about this for a second. Kw is this constant for this chemical reaction, okay? And if this is equal to this at a pH of 7, okay, if I'm talking about water, this concentration has to be 1 times 10 to the negative 7th, and this concentration has to be 1 times 10 to the negative 7th. And if I multiply those two together, I should get something that looks like 1 times 10 to the negative 14th. Because you know, when you multiply exponents, you add them. Okay? So we can use this information to calculate concentrations of either H or OH, depending on which one we're given in our problem. Okay? So let's look at the next page. So here, this is saying, if there's more acid added to the solution, we increase the H plus concentration. Where if more base is added to the solution, then that means I have less H plus concentration and more OH concentration. Okay? So let's look here. We're going to calculate the opposite concentration by using this equation to do that. Okay? So for example, if I have this value here, I'm going to turn it into scientific notation and it'll probably be a little bit easier. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 1 times 10 to the negative 10th is my concentration of H+. Now I'm going to walk through this step by step just so you can see how we can do this. Okay, so if I have Kw, which is equal to 1 times 10 to the negative 14th, so if I have 1 times 10 to the negative 14th is equal to H+, which I have right here, which is 1 times 10 to the negative 10th, and I'm trying to figure out what OH is, that's going to be my variable. Okay, so to get x by itself, I divide both sides by 1 times 10 to the negative 10th. 1 times 10 to the negative 10th. So x turns out to be, and when you divide exponents, you subtract them, so it's negative 14 minus 10, which means negative 14 plus 10. So my x concentration is 1 times 10 to the negative 4th. Okay? So who has the higher concentration? H+ or OH? You're looking for the exponent that's closer to 0. That's going to be your higher concentration. So in this case, this negative 4 is closer to 0, and that's my OH concentration. So that indicates, since OH is greater than H+, this solution is going to be a base. Okay? Why don't you go ahead and try number 2? That one's pretty straightforward. I'll look at number 3. Okay? Number 3, same thing. So I'm going to turn into scientific notation. So it's 2 times 10 to the negative 2nd. Okay? So to figure out what the concentration of OH is, I say 1 times 10 to the negative 14th is equal to my H+ concentration, which is 2 times 10 to the negative 2nd times x. To get x by itself, I have to divide both sides by 2 times negative 2. So x turns out to be, now when you do these calculations in your calculator, you need to remember to use your exponent button. Okay, so to plug this into my calculator, I'm going to say 1e negative 14 divided by 2e negative 2. So my OH concentration turns out to be 5 times 10 to the negative 13th. Okay, who has the greater concentration? 2 times 10 to the negative 2 or 5 times 10 to the negative 13th? This exponent is closer to 0, which indicates that my H+ concentration is greater. And since my H+ concentration is greater, that indicates that this solution is an acid. Okay, so go ahead and try the ones that we did not do in the video, and then we'll look at more examples in class. Thanks, guys.